Welcome, everybody. Sorry I'm late. We were just finishing up supper with the babies. Gracie was throwing hot dogs on the floor for Emma. Okay. I don't know if were you going to wait a minute or two to get started?
Yeah, well, people are still joining. It's 6:33. Maybe wait for another maybe 1 minute probably.
Okay.
And then we can get it started.
And you're, or it's automatically recording, right?
Yes, it's being recorded on the cloud. So everything is rolling.
And you could see my slideshow, no problem?
Yeah, I could see that, yeah.
Okay. Yeah, so whenever you want us to get started, we can get started.
Yeah, sure. Well, we can, yeah, let's get it started.
Okay, so welcome everybody officially. Typically, we like to see your smiley faces, but we'll make do the next best thing with our virtual open house here. My name is Dr. Ed Bednarz, and my colleague, Dr. Mohsen Ghamari. We're going to be presenting the mechanical engineering and engineering management programs here at Wilkes University. So we're very excited about our program, our curriculum. Hopefully that comes through. We have 52 slides, it looks like, but we're probably going to shoot for 45, 50 minutes to talk, and then we'll try to leave some time at the end for any questions, or if you'd like to type the questions into the chat, that's fine too. Whatever you feel comfortable with. But so we're going to talk about why mechanical engineering specifically. Both Dr. Ghamari and I have PhDs in mechanical engineering, and we're both extremely passionate about the field. So we're going to say why we enjoy mechanical engineering, why we enjoy teaching it, why Wilkes, why are Wilkes University mechanical engineering students prepared for the real world. They come out and they're able to get high quality jobs right after graduation. And how are we able to make that happen? Well, we're prepared. We've taken our time and really developed our curriculum. We have a mixture of lecture where the students learn the theory, but then they get hands-on lab experience where they get to touch the equipment themselves and perform their experiments, analyze the data, do lab write-ups, and learn how to write, which engineers, believe it or not, actually have to learn how to write too. We mentor them along the way. We're a good-sized program. I don't want to say we're small. Some of our classes are 20, 25, 30 students, but no more than that ever. So it really allows us an opportunity to truly learn the student's name. Especially by the time they get junior, senior level, we could be talking amongst ourselves and say, oh yeah, did you hear that Rich got a job at this place, or Sue is working here now? So we know our students and are able to help guide them because we've been there. We're engineers, all the faculty. We're going to talk about our facilities, our research, our collaboration. Senior projects. That's towards the end of their curriculum, their senior year, 7th and 8th semester. They get to design and build and test something on their own. So it's kind of their culminating capstone experience, we call it. Co-ops and internships. We've highly encouraged them to get their foot in the door with companies along the way, and that's going to help them get a full-time job when they graduate, which is the ultimate goal. Why else would you go to college? You want to get a job and be productive in your chosen career. So we're going to talk about integrity and community. So ABET is our accreditation, which Dr. Ghamari is going to talk more on, and beyond the classroom. We have reach out events to middle school, high school kids, kind of showing them what is engineering. I'll talk about that later on. And then, as I mentioned, we're going to have some time for conclusions. Okay, so our first segment here is why mechanical engineering. So I love this. It's a funny slide, but I think it sets the tone, maybe for this evening's open house. Why do you want to be an engineer? Physics conference. Are things made of stuff? Philosophy conferences. Is stuff stuff? Engineering conference. Awesome stuff. Could it be more awesome? We have fun in our department. We have fun with our students. But they learn the math and the physics, and they learn the integrity and what it means to be a good engineer in the real world. Engineers help people. They try to create products to make people's lives better. When they graduate, they join the Order of the Engineer. It's a beautiful ceremony, their senior year, and the Order of the Engineer, it's similar to the Hippocratic Oath for doctors, do no harm. So, engineers always are asked to act responsibly and morally in society. So, it's a wonderful, wonderful career. Here's another reason, why become a mechanical engineer? Well, if you ask the average person on the street, who gets paid the most in our society, they say, oh, my grandson's a doctor or a lawyer, but mechanical engineers do very well. And this is data right from ASME, American Society of Mechanical Engineers. The 2014 median salary for MEs nationwide is $83,000, so that's pretty comfortable living. But it's one thing to make good money, but can you get into that field? 277,000 jobs in 2014, predicted to grow to 290,000 in the next several years, and it's going to continue growing. There's always a need for people to make stuff for society. So that's the great thing about engineering. So we believe not only is mechanical engineering fun, but pays well. All right, so now I'm going to turn it over to Dr. Ghamari.
Yeah, well, speaking of jobs, let's look at the projection of jobs. I mean, there are a lot of different reasons that you may have for the major that you pick. But one of probably the most important is to have a career to support your family. And if you look at the data by the Department of Labor about the projected number of the jobs until 2026, so between 2016 and 2026, we see that the highest number is for civil engineers. It's the number, the first row, and then the second one is mechanical engineering. So that's promising. But we also, if you look at the sectors, the sections that the jobs, all of the jobs created in the next couple of years are gonna be related to, you'll see that most of them are in manufacturing section. And in manufacturing is what mechanical engineering is about. A lot of mechanical engineers eventually end up in manufacturing part of the industry. Well, civil engineers, they end up probably you see in the construction, a lot of them, not in manufacturing. So that means there's a lot of not in terms of the number, but also in terms of the diversity of the opportunities. There's if I ask you just name a couple of manufacturing companies, I'm sure you can probably name like 10, 20 in your area probably. Especially in the Northeast, it's a very rich manufacturing area. So there's a lot of opportunity in terms of job. And also interesting, the number 3 here is industrial engineering. We'll talk about engineering management, which is another program that we offer in our department, which is very, very similar to industrial engineering. A lot of our graduates in that major end up in positions of industrial engineering. So you see combined together, mechanical and industrial engineering are actually, they surpass the number of jobs for civil engineers. So that's I believe it's a very, very good motivation if you don't know what you want to do to probably think twice about continuing in mechanical engineering. Can we go next slide? All right, so why Wilkes? I mean, well, there are a lot of institutions in the area. Well, we have Lehigh University, we have Penn State. Well, here we have King's College. There are a lot of different institutions. For example, if you want to even go a little bit further, you can go to New Jersey. But if you're in the area, there are a lot of things that not every institution offers, especially big universities. They have a lot of research opportunities for higher levels, like graduate, PhD students, for example, postdoc researchers. But in the undergraduate level, there are things that small universities like us can offer a lot better. First of all, they're an ABET accredited university. So if you don't know, ABET is Accreditation Board for Engineering and Technology. It's a board that actually certifies and makes sure that the engineering institution, they offer, they follow the certain standards. So you see a lot of universities, they have it. Not every university is ABET accredited. Well, soon in 3, 4, 5 years, you will be probably looking for a job, and we'll see. Pretty much most of the companies, the number one requirement for them is to be graduated from an accredited university. So they say, okay, there are a lot of institutions that they grant degree, but not all of them follow the right standards. So we are ABET accredited. It's not new. We have been ABET accredited for more than 20 years, and we have gone through cycles of accreditation. So it's a very fluid process, and we are updating. We are making sure that we are conforming with the regulation. Probably after that, one of the best things that we offer is a small class size. Our class sizes in engineering, we shoot for something between 20 to 30. We try not to go beyond 30. If you go to large universities, like when I did my PhD, I was at the University of Iowa. I know Dr. Bednarz was at the University of Maryland. These are big universities. And typical engineering class is about like maybe 100, 120. So think about that. I mean, the instructor doesn't have the time to make eye contact with every student. That's impossible. But with 20 to 30, we know all of our students by name. Not at the end of the senior year. I mean, as soon as they have the first class with us, we know many of them just by name, and they know us. They know about a lot of things about our personal life. You know how many kids we have, and that's the beauty of a small class size. In a lot of technical electives, we have even smaller sizes. We have, like, for example, class of less than 10, 15, for example, and that provides a very good productive environment in terms of collaboration and learning experience. Facilities and lab, we have decent equipment in terms of education. It's not that like we only have them. A lot of universities have them, but what we probably offer is that if you go, for example, to big universities, we have, let's say we have a subsonic wind tunnel, for example. In big universities, they never let you to touch that. There is probably a graduate student working with that, doing the experiment, and the students are only watching, collecting data. But here, students, we actually we cherish that our students, they touch the equipment. We just train them, and they go and do that. Whether it's a robotic lab, whether it's a wind tunnel, whether it's a heat transfer, fluid mechanic, machine design, we provide some hands-on experience. We'll let them to kind of get their feet wet and dive into the actual work. So that's what we offer in terms of our facilities. And now we'll have the slides down the road. We'll show what facilities we have, what we can offer in terms of the specific areas of mechanical engineering. We provide all of our faculties, not just me and Dr. Bednarz. We have a lot of faculties. Everybody here is accessible and caring. I mean, it's very easy to find instructors. It's super easy. You just, stop by the offices. Again, think about that. We know pretty much every student by name. You don't have to go through a filter of a graduate student to meet us. No, you directly, schedule a meeting or just stop by. We are in our offices and you meet us, whether it's for advising, for your courses. A lot of students, they come and, we sometimes hang out with some of our, senior level. Our graduate students sometimes, stop by. So we are accessible to all of them. We provide co-op and internship opportunities. We take it very, very seriously. That's something that Bednarz is actually the coordinator of that program. We bring industries, we bring them to the campus. Aside from the job fair that we have, I mean, now because of the pandemic, everything is virtual, but we had the job fair twice, which most of the companies are actually engineering companies. They come to the campus. Aside from that, in the department, we bring companies. Like certain companies, we bring them to the campus and they interview students. So that's one thing we provide because we think it's important. And again, we'll have we'll talk about it in more detail later. And we have active student chapters of major engineering communities. For example, we have PSP, Society of Professional Engineering Pennsylvania, for example, American Society of Mechanical Engineering. It's an active student chapter. They hold, for example, the antique car show. They bring speakers to the campus. So if you want to be active, there are a lot of venues. Our ASHRAE is very active. Our SUI, Society of an Engineer. We also have students. They have Society of Automotive Engineers. They have the Baja, for example, competition. So if you want to get involved, we have all of these chapters. They have instructors, they have advisors around the faculty. So these are all of the things that we can offer that you probably, it's really difficult to have all of them together in a large scale university. Well, we can go next slide.
Okay, so kind of going off of what Dr. Ghamari was saying, what's our philosophy, as Wilkes engineering professors? Well, there's a lot of ways to classify what is engineering, but this is my favorite that I've heard. That engineering is the practical application of science for the benefit of mankind. So what does that mean exactly? Kind of going back to my comical slide, early in the beginning, scientists like to discover for the sake of discovery, and the world needs that. It's cool. Growing up, going in high school, I was interested in relativity and the universe and the Big Bang, and that's all great. But what do engineers do? We take that math, we take that science, the physics, and we create gadgets, gizmos, things that people can use. Right? This technology right now is developed by engineers. That we're able to talk to you all across the state, maybe the country, possibly the world, right? Just virtually. I'm looking at a computer screen, and it's mind-boggling that engineers come up with this kind of thing. The desk you're sitting on, the car you drive, this is engineering. So how do we make people's lives, happier, easier, entertainment? That's all engineering. So, I believe that engineering students, they entered this field. They were like, okay, I don't know what I want to do for the rest of my life. And hey, trust me, I was there. Dr. Ghamari was there. When you're a junior or senior, what do you want to do for the rest of your life? My oldest son's turning 15 this week. What does he want to do for the rest of his life? It's a very daunting task, right? I think that a lot of students that sign up for this program entered engineering through one of two paths: the practical, we will call the gearhead, or the theoretical, the book smart. So maybe you like tinkering with cars, or maybe you were just loving calculus in high school and physics, and you're like, yeah, someone guided you along the way and said you should go for engineering. You'd be a great engineer, and that's wonderful. I don't really care how you got here. Our goal as professors is to help you bridge the gap between the two and do both. A truly successful engineer can perform the theoretical analysis and the calculations and knows the math and the differential equations, but can also be hands-on, knows how to use a wrench, right? Knows how things go together. Because you can't design something if you don't know how it goes together and you've never tried it and been hands-on yourself. That we have a basic machining class that students take, and they get familiar with a mill, a lathe, a bandsaw, some welding, and they're encouraged to build projects along the way in the curriculum, especially senior projects. They're encouraged. Yes, you go down there with a machinist who has experience. It's going to help you safely navigate the equipment, but we want you being the ones to build it and learn how to be hands-on. And why would you have to do both? Well, depending on your actual place of work, you may be asked to lean more towards one or the other, but it's the most marketable when you have a balance. If you could put on your resume, yes, I have this tooling experience, or yes, I have these projects I've worked on. So our goal as professors is to inspire you to invent, create, and excel in life after Wilkes. You're here short 4 years. Trust me, it goes by very quickly. But we want to prepare you so that you could confidently enter the workplace. This is a great slide. National recognition at Wilkes University. Who outside of this area has heard of Wilkes University? Well, hopefully the word is going to spread. The economists, I always pronounce it wrong, did a college ranking where they looked at expected earnings versus earnings after graduation. And they determined that Wilkes University was 25 out of 1,200 colleges. That's awesome. The Wilkes in general can help take students with lower earning potential based on economic, academic background, help them find well-paying jobs. And I humbly say that that's probably mostly due to our department. Maybe Dr. Ghamari would agree with me. I think that the mechanical engineering department really helped this statistic in particular. And look who we beat out at number 26, Massachusetts Institute of Technology. I don't know, anyone heard of MIT? All right, I'm going to turn it back over to Dr. Ghamari.
All right, so, well, now let's see what this program, what do we offer, and let's become a little bit more technical. So first of all, we said that we are ABET accredited, and because of that, there are certain guidelines that we have to follow. ABET has a certain number of outcomes. You see all of them, and I will go through them very quickly. And these are not just some terminology. These are not some words. These are not basically formalities. The fact is that we have to build all of those outcomes. We have to build our curriculum in such a way that we're resulting in those outcomes. So you see, they are actually, they begin with very early courses. They are foundation, and they are built on top of each other. So the foundation are basically the problem-solving technique using math and science, and that's why the very early courses like math and physics are very important. Then is as design, it's just to learn how to create solution for given problem within certain constraints. Because I mean, if you don't have any constraint in the real world, it's very easy to solve every problem, but there are always constraints. There are very, very physical constraints. So you have to learn how to come up with a real solution, come up with a realistic solution. Communication is another thing that we early on, we try to develop in our student. So not just to be able to better communicator to your friend, but to learn how to communicate science and technical, to have a technical language. We try to build that in many courses, specifically in our senior design, that a student will have to kind of present for a large group of people. We have a lot of opportunities for a student to learn about the communication in different courses. And it's not just verbal communication, it's also written communication, writing, that sort of stuff. Ethics and professionalism, it's very important in engineering. Aside from the fact that we have a course specifically for that, but we try to kind of focus and emphasize on that in many different courses, how to be ethical while being an engineer, while for example, coming up with a solution. And you have a lot of, there are a lot of stories that you hear every day. I'm going to give you one example. For example, you heard probably about the scandal a couple of years ago. I think it was 2015 or 16 in Volkswagen. And they had the emission issue, and they had kind of falsified some data. They had fabricated data. Yeah, our engine are following the European standard. They're following the American standard. They don't emit much toxic gases. But it turned out that no, they are actually beyond the threshold. And some of the engineers, for some reason, they were under a lot of pressure, whatever reason, they made that mistake. They were not ethical. So it's not only costed the company a couple of $1 billion, but also for during all of those years, they hurt the community, they hurt the environment. So it's important to be ethical in engineering, like the way that you have to be ethical in other fields, like for example, in medical field, which is very, very important. The same thing applies to engineering as well. Teamwork, we try to build that also in our curriculum. Again, senior design, our capstone culminates all of different aspects, but we also have the teamwork in many different courses, how to learn how to kind of communicate with each other, learn how to work together. Experimentation, obviously, we have a lot of different hands-on and lab courses. Sometimes I believe we offer more labs than a lot of larger universities, with more equipments, with more kind of tools, because we want our students to know how to not just use their math and their brain, but also know how to use their hands. And also finally, which is probably the last and the most, but not the least, is the new knowledge. So you learn a lot of these skills, but you need to know how to apply that into different areas, and also learn how learn how to learn. You know, it's not when you graduate, it's not the end of your learning opportunity. It's just life is a learning opportunity. And we try to kind of teach you to look at the world differently, change your vision, look at the world as a learning, you know, environment. All right, so we can go next slide, please. All right, so aside from those major outcomes, our program has some program educational objective. We call it PEO or POs, like specific outcomes, which we try to, well, the goal of that is that at the end of the 4-year, we try to nurture these capabilities, and these are the 4 major outcomes and objectives that we try to nurture in our students, and we are really successful. Look at our graduates when they end up in terms of the job market, or if they want to go to higher education, which university they go. Well, I have a student now, he started PhD in Georgia Tech. We had a student, they went to Carnegie Mellon. We sent a student out to Penn State, a lot of very good universities. And also companies, if you look at them, they end up with very, very high-ranked, prestigious companies. And that's because of these objectives that we try to satisfy. So competency and professionalism is one of them. The other one is to design, develop, refine, and implement system products. We try to kind of achieve to the point that our members are leaders. They learn how to be collaborative, lead the project, take ownership of the project that they are assigned to, and also communicate effectively. It's really impossible and difficult to be a good engineer and not to know how to communicate. It's really difficult, and that's what we try to kind of, you know, to nurture, and we strive to reach to a point that our students, our graduates are very, very great communicators. All right, so I think now we can go probably a little bit in more detail into our curriculum. Let's see next slide. All right, so what we see here is we call it curriculum. You probably know what that is. It's the list of courses that we offer, and it's the pathway to graduation. So we are a 4-year program, 8 semester. We have summer semesters as well. It's not included here because it's not required. You don't need to take courses in the summer or intersession to graduate on time. You just need to follow this schedule. I have students, a lot of my advisees, they follow exactly the same curriculum. I mean, in the 4th semester, they take exactly the courses which is listed here, but it's not like that you have to do that. There are some flexibilities. The schedule is not rigid, such that if you, for example, fail a course somewhere, you will end up in 9 semesters or 5 years. No, that's not the case. There are opportunities to kind of to shuffle some of the courses. In some areas, there is a little bit of kind of wiggle room. In some areas, you can move courses kind of, you know, more up and down. So the first year, the first 2 semesters are the foundation courses. If you look at them, there is you don't see any mechanical engineering course except the ME180. That's basically CAD. You learn how to do drawing using AutoCAD and SolidWorks software. And these 2 semesters, the courses right here, are the same for mechanical engineering, engineering management, electrical engineering, as well as environmental engineering. So these are all of the engineering programs that we offer as of now. We are working to offer civil engineering. I think we are in the process of approving that pretty soon, I believe. I don't have the recent news on that, but I guess probably in a year or maybe less, we're gonna have civil engineering as well. So, well, if you have that, the first 2 semesters for that is gonna look like the same. These are the courses that all of the engineers should take. And that kind of, you know, it's a little bit difficult. A lot of students are discouraged at the end of the first year because they are so passionate about all of those fun mechanical engineering courses. But that's when we tell them, you know, hold your horses. You have to be patient. Once you finish the first year, at the beginning of the 3rd semester, that's the fall of the sophomore year, there is still more of a foundation courses, but we begin going into engineering. We have, for example, electrical circuits, which is again something that all of the engineering courses students take, as well as the first mechanical engineering course, which is statics. It's a very, very fun course. But then look at the 4th semester, and right here, pretty much all of the courses are mechanical, or EGR, which is mechatronic. Only mechanical and electrical engineering students take. So the bottom line here is that if you know that you want to do engineering, but they still have some doubt between mechanical, electrical, environmental, or management. So it's okay. You can begin your first year as an undeclared engineering student. That's okay. And by the end of the first year, you can choose your major. So the first year is the same for all of them, exactly the same. There is no difference. You can also begin the third semester kind of undecided, but probably by the beginning of the fourth semester, you should know what you want. And I believe that the first year gives you the opportunity to kind of to hang out with friends from different majors, and you will know. We have a pretty good number of students that kind of switch major during the first year, and there is no enforcement. I mean, we once you choose, for example, mechanical, if you want to switch to environmental or vice versa, you can always do that. There are courses here that you see are called general education. These are courses in the area of, for example, humanity or non-technical courses, like, for example, English, economy. There is a range of courses. It's overall about 30 credits that you have to take, like maybe about 9-10 courses that you have to take. It is not 10 fixed number of courses. There are certain courses that you have to take, for example, like history. And there are courses that you have to choose from. Like, for example, you are given an option between psychology, anthropology, sociology, and you have to choose between them. And that's actually good. Sometimes there's a lot of technical courses in a semester, and you really need to kind of, get out of engineering courses. You need something to change the flavor. And that's what I recommend to my advisees to kind of spread them around. Some students want to get rid of them as soon as possible, but it's a good practice to kind of spread them around, and they change the flavor. And meanwhile, you hang out, with other students. There are cool courses, especially when you are in engineering courses. You really understand the value of courses like in philosophy, why philosophy is important, a lot, especially like the philosophy of science. So these are kind of complementary to engineering courses. We have technical electives. You see probably begin in the junior year. Technical electives. We offer a wide range of courses in specific areas of mechanical engineering. So, for example, if you want to focus on thermal fluid area, you're interested in HVAC, for example, we offer courses for ventilation. We offer courses in thermodynamic, which are not part of the curriculum. You don't have to take them. But if you want to, for example, kind of hone your skills in a certain area, maybe if your target is a job, for example, in HVAC market, and you want to, right after graduation, want to go and get all of the certificates, so it's a good opportunity to take those courses. If you are interested in, for example, in manufacturing, we offer courses in micro fabrication. We offer courses. We have a very good 3D additive manufacturing lab, 3D printing. So we can take that. We can take, for example, courses in the machine design area with Dr. Bednarz, or nanomaterial. If you're interested in robotics, we have a certain section of courses related to robotic, for example. So it's up to you. You can change one from each area if you want to try each of them, kind of get some knowledge, or if you want to have a deep understanding of a certain area, it's totally up to you what you want to do with those courses. So that's our job, is to provide the pool of good courses, and then you have to choose among them. We have a co-op here, if you see, in the third year, in the sixth semester actually. And a co-op is when you go, and again, Dr. Bednarz will talk about it. When you, during a semester, will go and work for a company. If you find the opportunity, there are a lot of companies in the area that are interested in students. You will be paid for that. You will get some experience. A lot of students are hired after graduation by the company that they interned for, or the company that they have some co-op with, because they know them. It's just a lot of things based on they know about them. They know what are the skills they need. They have developed their skill in that period, for example. And the most important is that you can use that co-op towards your degree. So up to between 3 to 6 credits. So you can choose 2 of those technical electives to be your co-op. So you go to work, you get some experience, you are paid some good money, and At the same time, you are passing 6 credits. So that's why we value here those co-op courses. Here is the same curriculum that you saw, but here is we call it flowchart that tells you, shows you what is the order of courses. There are basically 3 categories. You probably can guess. Those in green are math and science courses like physics and chemistry. Those in purple are mainly engineering courses, mechanical. There are some EGR, which are engineering courses. And those in kind of light, I don't know whether it's orange, I guess, or light brown, they are general education courses. They are connected with arrows, if you see. The arrows are, we see 2 types of arrows, the solid arrows, which means if 2 courses are attached with a solid arrow, that means that the course in the upstream is prerequisite to the course in the downstream. That means that you have to take this one first, pass it, so that you can be allowed into the second course. If they're connected using a dash line, that means that you can't take these 2 courses at the same time. That means that's co-requisite. And if you see that we do not have any we call it critical line. We don't have any critical line that connects a course after a course after a course for the 8th semester. Some schools have it. That means that if there's a critical line, if you fail a course somewhere in between, there is no way but to finish in more than 4 years. We don't have it. We try to there are courses that are offered in more than 1 semester. There are courses that we offer every semester. So we try to provide the opportunity. There is not only one pathway. This is the optimum pathway, obviously, but this is not the only pathway to graduation. And that's why we are, aside from being the instructor, professor in research, we also provide a lot of advising for our students. What is the right pathway for them to graduate? So this is for the mechanical engineering. Well, that's my daughter. All right, I'm sorry for that. So she was sleeping. She just, yeah. All right, so that's a little bit flavor because of the pandemic. So this is the curriculum of our engineering management. So we not only offer mechanical engineering, we also offer engineering management, which kind of gears towards the managerial part of the engineering projects. You see that the first 2 semesters are very similar again. Pretty much all of the courses that you take as a mechanical engineer. There are a lot of technical courses that both mechanical and engineering management take, like for example, fluid mechanics, thermodynamics, fundamental courses, because how can you manage a project if you do not understand about the basics of it? So there are certain courses that they take, but if you look at the courses, especially in the 3rd and the 4th semester, the focus of the courses, they are geared towards the management or the finance aspect of the project. So how to control project, how to plan for a project, how to finance the project. So what are the aspects of a successful project it is? And it's very, very similar to industrial engineering. Again, this is not industrial engineering, but if you look at that, a lot of our students, I mean, pretty much all of those who graduate end up in positions which are open for industrial engineers. And that's another thing. We can go back to the slides that we had in terms of number of jobs for mechanical and industrial. Number 1 was civil, number 2 was mechanical, number 3 was industrial. So mechanical and engineering manager combined, they are actually number 1 in terms of number of jobs created in the next couple of years. Overall, both majors, they need you to take 130 credits. You can take obviously more than that. I have students take more. Aside from these majors that you choose, you can also choose a minor. We offer, for example, minor engineering management, which means that if you are a mechanical engineer, by taking an extra 6 credits, if you are careful in terms of planning your courses, you can also get a minor engineering management. There are minors that are offered, for example, in physics, the same way. If you are smart in terms of taking your technical electives, you can take courses that count towards your ME major and your physics minor. So a lot of students they end up taking, instead of 130, they take 136 credit, which is easily manageable in 4 years, and they take both a major and a minor. Here is the flow chart. Well, I'm not going to go over that. You will have access to all of these documents, but basically, you see, well, we don't have much of an AME courses. There's a lot of EGM courses here, which are engineering management. And again, they are more about the management, how to lead a project, how to control a project, how to finance a project, the managerial aspect of every project.
Okay, so now we're going to talk about mentorship and get into who we are as faculty and staff. And I know this seems like such a cliched slide, but we totally stand behind it. We truly are faculty that cares. And Wilkes is primarily a teaching school where our undergraduate education is emphasized. It's not just, oh yeah, by the way, we also offer a BS program. That's our main focus. We do have a master's program that we've been trying to grow, and we have master students that we work with research on. But a lot of our research, and I know Dr. Ghamari and myself, most of our research actually occurs with undergraduate students helping us. So I think that also makes us unique. Our students are well prepared for industry and graduate school. We have many students. They go on the Lehigh for PhD program. I know Dr. Ghamari mentioned a few different schools. They'll go on for master's degrees, PhD, or right into industry. One thing that I thought of with the economics slide earlier on, our students typically get jobs in the $60,000 range starting salary, which in this area, which I'm a local from NEPA and from Hazleton originally, and that's a good money. That would be good for a whole family, let alone one person. Our instructors do offer hands-on experience, and we've said it many times already that the professors really do know the students' names. There's Dr. Ghamari and this this lovely brochure here we have, just kind of showing, and that's a quote from one of our students, Rich, who a great student we had. I think he's going for his master's now currently. He graduated with his bachelor's, and he's sticking around for another year and a half to complete his master's in mechanical engineering. So that's a possibility. So here's just a brief look at who we are, kind of put some names and faces together. What I like to highlight from this chart is mechanical engineering is very diverse. There's many different areas. My area is mechanical design, solid mechanics. Dr. Ghamari is the completely opposite end of the spectrum. He's thermal science, fluid mechanics, heat transfer. Dr. Bednarz is nanotechnology, nanomaterials, and our chair is Dr. Henry Castajon. Mr. Mitch Adams, he's a machinist in the machine shop, really loves working hands-on with the students. He actually does teach the machining course, which I do believe was 4th semester. And Mrs. Lisa Colavetti, our office assistant, but she helps kind of keep the engine of the program running. She's always available for questions for students that stop by. If they're looking for a faculty member or need help with a form, she'll greet them with a smile and useful information. So I think this is the rest of our department here. Dr. Jamal Garishi, he's in a similar area as me. I actually had him as a professor 20 years ago. I'm a product of Wilkes myself. And then I went for my graduate program down in Maryland, as Dr. Ghamari said, worked for the Army for 11 years and came back. Now I'm teaching full-time at Wilkes. So I couldn't stay away. I love Wilkes too much. Mr. William Greiner, he's a similar area, but he comes with a lot of industry experience, and he's really heading up our engineering management program. He's doing a fantastic job with that. Dr. Perwez Kaleem, I think we could call him Dr. Ghamari's counterpart, kind of his mentor in the thermal fluids field. Dr. Xiaoming Mu, he's doing a great job with our additive manufacturing lab. If you go in the first floor of Stark, we have a wonderful new facility that recently got dedicated 3 years ago, I believe, with 3D printing and manufacturing, a lot of emerging technologies. Dr. Ali Razavi, he's a similar field to Dr. Bednarz, nanotechnology, MEMS. we also have another lab that just recently got dedicated in that area. Dr. Yang Zhu, he's robotics. That's another aspect of mechanical engineering. So, mechanical engineering is extremely broad. And, Dr. Ghamari did a great job talking about our curriculum. What we offer is the breadth. So students will take fluids, machine design, robotics, but then we offer the depth. So if they're like, no, I really do like this robotics field, I want to learn more about CNC and PLCs, they can take the technical electives. Here's our dean, Dr. Prahlad Murthy. Okay, so Dr. Ghamari, I think this is you. We're going to talk about facilities and research.
That's right. So we said that one of the things that we really, cherish here is the hands-on skills. We try to kind of, we encourage our students to, aside from a lot of different labs that we have. I mean, there are so many labs that you have to take. It's actually make the courses a lot more fun. It's not just theory. You don't go and learn about the formulas and solve problems, but you go to the lab and see how they're applied. Different measurement techniques, different instrumentation, for example. And we have so many labs. We use them for both teaching and research purposes, and that's separate from the faculty's research lab. Like I have, for example, my own lab, which I don't use it for teaching, it's just specifically for research. But I have both undergraduate and graduate students that they work for me, especially in the summer. If they want to stay on campus, they want to do research, we have a lot of projects for them. So here you see the image of, well, if you go back, yeah, thank you. It's our subsonic wind tunnel that we have. That's one of the things that we have. We have the pretty good machine shop. We have a lab for mechanical system design, vibration. We have combustion lab, which is my research lab. We also have a lab for students who they want to work on internal combustion engines, especially those who are interested in Baja project, for example, the Baja competition. We have a motor fabrication lab. That's if you want to take, for example, course in motor electrical mechanical systems. We have a motor fab, which is shared by both mechanical and electrical engineering departments. We have robotics. Again, we have robotic for teaching and robotic for research. Heat transfer lab, fluid mechanics lab, additive manufacturing, which is something very new. We just got it about 2 to 3 years ago, with so many different 3D printers. Aside from 3D printers that we have in machine shop, we have a lab specifically dedicated to additive manufacturing. And it's not just that you take your drawing and they make it for you. No, we have Dr. Mu offers the course, and they go over the theory. And they work, they spend a lot of time in the lab, working with different type of printers, different concepts, and that's a very good skill now if you want to go in the market to know about the prototyping techniques that a lot of companies are now kind of moving towards 3D and kind of fast 3D printing and fast prototyping. We have very nice computer labs. We just equipped them just recently this year with new computers. Here you see some images of our robotic lab and also some of the projects that a student do. So it's very hands-on. Students learn how to kind of program microprocessors, boards, how to, for example, work with different motors, servo motors, for example, infrared detection systems, how to develop a control mechanism for them. So again, these are all individual student projects, and these are course projects, not just research. In front of the research, Dr. Zhu also has a separate research lab that is that interested student can work for him. Yeah, next slide, please. Aside from, again, that, I mentioned the research labs that I have my lab, Dr. Bednarz. This is a project from, I believe, one of Dr. Bednarz's master's students. We offer master's program here in both mechanical engineering and engineering management. And our students have the option in master's program to do either a thesis, a 6-credit thesis, or if they can do 3-credit projects. The project is kind of, compact version. It's kind of faster, simpler, but a thesis is a more kind of fundamental, in-depth research Students that work on research or even projects, they end up, we would go to conferences, we publish. I believe this work was published by Dr. Bednarz and his master's student. They publish in journal papers. And again, it's not just graduate students, a lot of time undergraduate work in the lab. And that's a good opportunity. I mean, I was talking to somebody yesterday from our marketing department, and that's something I really enjoy working with undergraduate, is that they really express themselves without any hesitation, without any reservation, you know, and that's because of the passion that you have. And I really encourage you. I mean, don't be shy. I mean, whether you're going to end up with mechanical or electrical or any engineering major or any field of science, just keep the passion. I mean, for me, when I'm a little bit more expert in a field, if they want to come up with idea, I have a lot of reservation to talk about somebody with that, because I want to make sure that it's right. I don't want to kind of, you know, look stupid. I don't want to look goofy. But as an undergraduate, you should not have, that's not the right attitude. And a lot of time, my undergraduate, they really offer very, very good, awesome, brilliant ideas about research. And again, we provide the platform for them. We just provide the platform, and after that, it's up to them if they want to work on any research, kind of, you know, sharpen their skills and kind of add something to the resume for future careers. Here, I believe, is one of the Dr. Bednarz. Well, that's not how every research lab looks like, but sometimes it's like that. I believe this is Dr. Bednarz. Inverse engineering is one of the technical elective courses Dr. Bednarz offers, and his lab is a lot of time, you know, is shared by different students from different courses. I guess some of them are senior designer students, and you see how interactive the environment is. There are a couple of students are working with each other. The guy, which is, it seems to kind of be sneaking on them. I think it's he's probably Anthony, and he owns a company, I believe. I mean, this photo is from 3 years ago, and he owns his own company. He kind of recycles material and used for machining purposes. And this very interactive area, again, I really miss those pre-COVID period, and I hope, I mean, this will pass eventually, and we'll be back to that environment, how the collaborative environment is. I see some Legos, I believe, and that's probably because of some of Dr. Bednarz's outreach activities. We bring, like, you know, elementary, middle school students to kind of, we have some STEM outreach activities. So we try to kind of, you know, always add flavor and kind of fun into our work.
Yeah, well said, Dr. Ghamari, and he's right. I think this was towards the end of the semester, so we have senior projects going on, maybe 2 different senior projects team, but, you know, and the outreach event. But we also do encourage the students to collaborate amongst themselves and help each other. You know, I'm the coordinator for senior projects, and we have any given semester 12 teams, all working on projects with dedicated faculty advisors that I'll talk about in a short moment. But I start the course by saying this is not a competition with each other. You can help each other. You know, if someone has a good idea and say, well, I used this type of motor or this Arduino on this other project and it worked good. Hey, you might want to try it on your project. You know, we really want to foster this collaborative learning environment, you know, with the students, with the faculty. They can have a dedicated faculty advisor. Dr. Bednarz can be their dedicated faculty advisor, but if they're starting to run into issues with the fluids area, they're going to knock on Dr. Ghamari's door, and he'd happily help them out, even though that's not his assigned team. You know, so we really do try to encourage this collaborative environment. And hey, that's a nice segue into this next section. So here's our poster from our most recent senior projects presentation. So from the flowchart that Dr. Ghamari talked about, our typical pathway would have the students taking senior projects 1, their fall semester, senior year, so semester 7, and then senior projects 2, their spring semester of 8th semester, and then they would graduate in spring. We also, some students, by whatever means they get out of sequence. We have a lot of transfer students, and maybe they came in a semester out of phase, or, as Dr. Ghamari said, they may have struggled early on, failed a calculus class, a physics class, have to retake it, and maybe they could graduate in 4.5 years instead of 5 years, or sorry, instead of 4 years. So what we've been doing in the last couple of years, it's been working out great, is we offer Senior Projects 1 and Senior Projects 2 both semesters. So preparing for this upcoming spring 2021 semester, we're going to have several students that are going to start their Senior Projects 1, while we're going to have Senior Projects 2 finishing the same semester. So we have a culminating presentation every single semester. So every fall we have a presentation for both sections, and then every spring we have a presentation for both sections. Basically, semester 1, the goal is to have their design complete, work with their teams, work with their advisors, and then semester 2, have the physical build, the testing, and the conclusion to their project, basically. And we encourage their creativity. I'd say most of these projects are grown organically through the students. I would think that Dr. Ghamari would agree with me there, that they came up with ideas amongst themselves. They find an advisor to talk with and say, hey, I have this idea for EcoWing. It's basically an add-on for a pickup truck to make it more aerodynamic. And then they're working in Dr. Ghamari's lab to try to test the fluids flow and the drag. So we really encourage, and they came up with their own logos. These are students that are very creative. It's never ceases to amaze me what they could come up with. Here's the website to Senior Projects if you want to check it out. Wilkes.edu/ME Senior Projects, all one word. And I know we're kind of running short on time. We're at the 59-minute mark, but if you want to bear with us, and we'll hopefully wrap up in the next 10 minutes. I'm just going to go quickly through just some senior projects. This one was a project I worked on with my students. My wife, Heather, is an occupational therapist, and she had this idea for an adjustable wheelchair. So we worked with the Senior Projects team, and we ended up getting it patented, and now we're trying to sell it to a wheelchair manufacturing company. We think there's a need in the real world for this. So, Dr. Ghamari already mentioned that we work with students that, we present at conferences with them. We get published in journals. We could also get patents with them. Here was a real-world project students worked on. They helped convert an old church, Catholic church, into a parish center. So they had to do, different creative engineering to turn these pews into different benches. And then they did some analysis on acoustics, because a church is built to project acoustics, but this parish center was supposed to be cubicles where we don't project anymore. So they did some acoustics analysis and electrical analysis, and got to work with customers. This was totally a student's idea, but it was a fun one. This was for a bar, automated drink mixer, basically for the bartender to say, just push a button and say, I want a Long Island iced tea. And then they had a system that would take different shots from different bottles. What you're seeing there is just colored liquid. We assure you, there was no alcohol on campus there. But I thought that was a fun real-world project they came up with. It was a nice electrical, mechanical collaboration project, cross-discipline. We may wonder, why is robotics and mechanical engineering? Isn't that kind of electrical engineering? Well, it's both. And as our students can graduate as a mechanical engineer and end up doing programming and robotics, and so we try to give them exposure to sensors and robots and different aspects of engineering as a whole. Here's a fun project, the Rube Goldberg machine. Basically, it's a overly complicated way to do a very simple task. If you've never heard of Rube Goldberg, take some time after this presentation and just type in Rube Goldberg machines in YouTube, and you will not be disappointed. This was a great project. These, and all these they came up with by the students themselves. They found a way to turn gravity into power to charge a cell phone. So say you're out in the woods and your cell phone dies, you basically hang some rocks from a tree and let it fall. So you turn this gravitational potential energy into kinetic energy as the rocks are falling, and then that spins a motor and charges a cell phone enough to make an emergency call. Brilliant idea and wonderful execution. Kraken board sports. Here's a couple of great students we had. You know, as Dr. Ghamari mentioned about Anthony Prado earlier, he started his own company. These guys here, Dan Likens, Mike Robinski, they started their own company, and they're still selling these units several years after graduation. I just saw Danny, you know, pre-COVID, we went, you know, for a sandwich on the square, and he said, yeah, we're doing well. And basically this was a way to snowboard on flat land or wakeboard without a boat. So, you know, they were sports enthusiasts, I guess you'd say. They love wakeboarding and snowboarding, and they wanted a way just to create a winch system to do it for themselves. Here's just a couple other senior projects. Pumpkin Chunkin, you may have heard of that, where we launch pumpkins. So this team, they built their own Pumpkin Chunkin, and they were launching pumpkins across the greenway. Public safety sort of walked by, paused, saw what we were doing. I said, don't worry, it's for engineering. It's all good. And you know, the security guard would just keep walking and shaking their head. Oh, those crazy engineers, they're always doing something nutty. This was a great real world project, a high lift dump trailer, where it was a way to dump. So basically, if you had mulch and you had to dump it over a fence into a yard, it would lift up with the scissors lift and dump. And I was the advisor to this team, and when they were first pitching the project to me, I said, hey, you guys are going to go way over budget. The students are given a $500 budget, you know, an actual engineering constraint that, you know, you could build whatever you want within this $500. And I said, you're going to be an order of magnitude or more above that. So they actually went out and found a sponsor to help them build this. And they actually got it working, and they built it, and there it is in the parking lot of Stark. You know, amazing the initiative these students have. Here's a snippet of what the senior projects presentation will look like. This is in Stark 101. This actually, we don't have any classes in Stark 101. This is a couple hundred seat auditorium, I suppose. None of our students typically take a class here except for their final senior projects presentation. But it's amazing, watch them start out as sort of shy freshman, sophomore, presenting to a class in front of 15 people, you know, maybe being a little nervous. And then by the time they get to their senior level, they're confident, they're dressed nice, and you know, they're business casual and business formal, and they're confidently saying, hey, this is what I built and this is what I made. So it's wonderful watching their evolution as students. So here's kind of just a snippet of the co-op that Dr. Ghamari said, and here's some companies. You know, it is unbelievable how many local companies there are in this area that are eager to hire Wilkes engineers. And here's just another slideshow of some companies and their logos, but I really got to highlight Sharon Castano on the right. She's the director of internships and co-op education for all Wilkes students, but I think she has a special place in her heart for mechanical engineers, and you know, specifically, she helps them with their resume. She helps them with interview skills. She helps them get a LinkedIn profile. You know, how do you land that job? How do you land that co-op? And most of the time, if they're able to get their foot in the door as sophomores, juniors, seniors, maybe work as summer at a company, and then, you know, during winter break or even throughout the semester, 10, 15 hours. And usually the company will hire them. You know, if they say, yeah, Joe or Sue or Bob, you know, they're working out great. Yeah, do you want a job? You know, so you know, we highly encourage these students to get their foot in the door while they're students, and that really helps them in their path. Here's a collaboration with local company. We worked as a partnership with Mountain Productions. This was an independent studies team I had, where they took a problem this local company in Wilkes-Barre needed. They Mountain Productions, they deploy temporary flooring for events, you know, think huge graduations or carnivals, and then when they take them back, they're covered in dirt and grass, and they need a way to wash them. and they were manually power washing every one. It would take them several minutes per panel, and they would have several hundred panels. So, our students, they came up with a way to cut time, 10% of the time, like 1/10 the time, and greatly increased productivity for this company. And it was partially funded by the Ben Franklin Institute. So many thanks to Ken Krepke on the left for helping to fund the project and help the company out. So it was a win-win-win situation. Our students got experience, and they got to use their engineering knowledge and get hands-on real-world experience. The company got a working system that they loved, and it was a great project to work on. Here's the last couple students I want to highlight. Adam on the left and Andrew on the right, working at Toyota in Michigan. Adam, Dr. Ghamari, and myself, we both knew him exceptionally well. I think he was your advisee maybe, but he was a very passionate student, and right from the get-go, he said, "I want to work for a car company," and that was his dream, that was his goal, and we encouraged that. We said, "Yeah, that's great. Let's get you there." And Sharon helped him out, and then we worked with him on several projects and helped with his resume, and now he's working in Michigan for Toyota, and he loves it. And he's a guest speaker now that comes back as part of our lecture series. Okay, so now I'm going to turn it back to Dr. Ghamari just for the last couple slides in conclusion, and then we'll stick around for any questions. So just hang out with us for a few more minutes.
We are short in time, so let me just quickly skip over these through these slides. So again, we have a lot of websites we are able to accredit, and we have a lot of we try to kind of encourage a student to get involved, not just to take courses, pass with some good grades, but also engage in community, whether the local community or the scientific community, professional community. That's why we have all of these professional student chapters of ASME, SUI, ASHRAE, Society of Automatic Engineering, SAE, for example. Aside from them, we have like every week, Tuesdays and Thursday between 11 to 1 p.m. We call it club hour. And that club, during club hour, those 4 hours total, there's no classes across campus. We're not allowed to have classes. We're not allowed to have meetings with students. That's 4 hours for students to engage in the student activities. And there are a lot of different student groups and activities, again, aside from like a student council, many different clubs in the university. And a sport group, for example, if they want to, for example, get involved, and we encourage them, the school supports them, it finances them. If they want to invite outside lecturers, speakers, for example. There are so many opportunities. If you want to get involved in the community, there is opportunity for that. Next slide, please. We get involved in outreach programs. Again, our students a lot of time help us with that. Here is, I believe, Dr. Bednarz lab, an outreach activity for 5th graders. And again, that's what we do. We try to kind of give back to community, and we encourage our students to do that. I mean, we are nothing without the community around us. So they support us, and we try to kind of support them. Next slide, please. All right, so for the conclusion, mechanical engineering is a very, very rewarding career. Well, in general, engineering is very rewarding, not just mechanical. Mechanical engineering, especially because it kind of, you're working a lot of time with your hands, you're touching objects, you see what you make or what you design in outside world, in the physical world. A lot of time it's very rewarding, especially for people who are a lot kind of more extrovert. We try to give you the skills. We try to kind of nurture the skills that you need to design and to become a good engineers. And how are we are different with other schools? Well, we try to kind of we give you the hands-on experience, caring faculty, industry connection through co-op internship in our Office of Industrial Collaboration. We have a Kirby Center that provides a lot of opportunity to collaborate with industry. And also small class size. Again, something we try to kind of make it a very, very friendly environment between the students and faculty. Here is a statement, is actually a quote by Steve Wozniak. He's a co-founder of Apple with Steve Jobs. They founded Apple. I think he's a computer engineer, but his statement, I believe, is true for all of engineers. Well, let me read that. I hope you'll be as lucky as I am. The world needs inventors, great ones, obviously. You can be one if you love what you do and are willing to do what it takes. It's within your reach, and it will be worth every minute you spend alone at night. And that's really true. It's really rewarding. Every minute we spend alone at night, thinking about what it is you want to design or build, it'll worth it, I promise. And again, that doesn't matter whether it's a mechanical component, electrical engineering, or you're developing a computer code. The time that you spend, the outcome is always rewarding. So I think that concludes our presentation. We went a little bit over time. We are still open for questions. Some people asked questions in the chat. I already answered them. There is one more question here by Matt. Let me quickly go over the question people asked and answer them very quickly. Well, first question was, are any classes taught by graduate students, or they are all taught by professors? No, we don't have graduate students teach classes. We have them helping us. For example, when I go to a heat transfer lab, sometimes I have graduate assistant that help me because it's difficult to kind of answer all of the question, but I am the person who is in the lab for the whole duration. When it comes to lectures, we never have any graduate student. They typically help us in terms of grading assignments, or if there's a project hands-on, they help us to kind of, two people is a lot better than one people when it comes to like maybe 20 students. But all of the classes are taught by professors. The other question was, all courses are offered by, the question was about the teamwork, and do the students have to wait until the senior design to work as a team? Well, that's not the case. A lot of our courses, they have team project. Like for example, I was co-teaching a MEMS microelectromechanical system with Dr. Razavi, and we defined project, students in team, actually they did that. It was a multi-component project. We had to kind of do microfabrication. We took them to Lehigh University for part of that. In robotic projects are team projects. I think Dr. Bednarz in machine design, I don't know if there's a project or not. Sometimes these are individual, but no, we don't wait for students to get involved in teamwork until the last year. We begin from early on.
Yeah, actually, let me chime in quickly. Every single class I teach, I have a team project. I teach statics, strength of materials, machine design, inverse problems, advanced CAD, machine design too. Every single course I teach has a team project. So yeah, we definitely want to get them used to working with their peers and collaborating and group work. And yeah, so pretty much from freshman year on, I teach freshman course, the FYF course. Yeah, from freshman year on, we want them working as a team. So yeah, go ahead.
Yeah, that's right. The other one, which is a very interesting question, is about students involved in sports. What the question is, engineering, because it's very demanding, is it possible for them? It is actually possible. We have quite a lot of students, student athletes in both engineering and very active and successful in the sport. Nico, for example, is one of my students. He's a double major in mechanical and electrical engineer. He is going to finish in 4 years, and he's also in the university lacrosse team. He's very active. We have one of my students, Nick. He's in the swimming team, and he's in mechanical engineering. He's going to finish on time, 4 years. He's 3+ GPA. We have students in tennis, lacrosse, baseball. We have other students in baseball. Dr. Bednarz probably knows more. Okay.
It's Ida.
Dr. Bednarz, yeah, it's Ida. Dr. Bednarz probably knows a lot more students. If they want to, well, there are a lot of sports. I think the university is part of NCAA. So if the students want to get involved in them, yes, they can. And we try to be flexible. There are certain times that the students have their exercises, and we try to be flexible in terms of assigning the assignments, or in terms of the exam time. We try to kind of be very collaborative, and that's something really doable.
Yeah, and just to touch on, I was a student athlete at Wilkes. I played tennis, so we have a really good tennis team now. They pretty much win the MAC every year, and I think Dr. Ghamari, I'm not sure if you mentioned it, but yeah, we try to help our advisees on a one-on-one basis as they're scheduling their classes. I have advisees who says, "Oh, I'm in softball, or I'm in lacrosse, and here's my practice times. Can you help me schedule around that?" Yeah, so we try to work with the students there. But yeah, it's both are demanding, that's for sure. We never try to sugarcoat the rigor of the engineering program. It really does take a lot of effort. It's not an easy degree, but if it was easy, everyone would do it. But no, if students are dedicated, we try to tell them, use your time wisely. If you're going back to your dorm room, are you just on YouTube for 5 hours, or are you getting your homework done? Yeah. So there's a lot of responsibility when you get transition from high school to college. And
now there's one more question that Ed, you may know better. The question here is: are there any additional scholarship opportunities for students willing to participate in any band program that a school offers?
That's a good question. I do know our students participate in the band, the music program in general, theater. Our students participate in all that. I'm not sure off the top of my head of specific scholarship opportunities, but I would say look around, talk to admissions, right, Dr. Ghamari? There might be a way to.
They definitely know a lot better. Also,
yeah.
There's a question for scholarship for international students who are unable to afford the costs. So I know that, again, this is the question that you have to ask admission program, because, well, based on the qualifications, they offer a packet. Actually, they may offer you some discounts, some scholarships. Some of them, I know that you have to be probably citizen or resident to be eligible for them, but there may be some funding available. And when it comes to discount, I know the university has much more flexibility. When it comes to bringing good talented student, the student probably is probably ready. Again, I don't know, I have to say it or not, but the school is ready to kind of stretch a little bit, be more flexible to bring good talent to the school. But make sure to talk with admission about that. They have the final word on that.
Are there any questions anyone wants to ask, just face to face, or I guess virtually face to face? If you don't want to put it in the chat, feel free to unmute yourselves at the bottom left. You may have seen them. There's a little.
Yeah, I don't see any question in the chat.
Click on the unmute button.
Yeah, if you want to ask questions using your microphone, yeah, feel free. I mean, that's also an option.
Or I think I put this up pretty quickly, but if I share my screen again, here we go. Here's our email addresses. I'm edward.bednarz at wilkes.edu, and Dr. Ghamari is Mohsen Ghamari at wilkes.edu. Feel free to reach out to either one or both of us if you have any other than that. I guess thank you. We hope to see you at Wilkes. Oh, one more just popped up in the chat. Do most academic activities go on during the week? Yeah, I think the club hours during the week, Tuesdays and Thursdays, 11 to 1, as Dr. Ghamari mentioned, and weekends as well. Yeah, they're pretty good about scheduling around
before
students.
COVID, for example, if there was no COVID, the campus and the academic buildings and Henry Student Center, they are open to students 24/7. Like our computer lab is open 24/7 for students if they want to work on their project or if they have a club activities. There are certain areas of campus that they are open. Again, it was before COVID. After COVID, there are some serious restriction, even for faculty. There are certain times that we can go to campus. But still, when it comes to the need and demands by students, we always find some way, as long as we communicated with the public safety, with our deans, we always, manage to get the permission for students. Again, once this COVID situation is over, there is a lot more opportunities. There is a lot more flexibility in terms of accessing what Wilkes can offer.
Oh, we got a question that popped up. Average class size again. They were asking about the average class size, Mohsen.
The average.
I think.
Probably that came to.
Well, I was just going to say that the lectures, as we were saying, what are some of the average class size for most classes? For the engineering classes, 20 to 30 for lectures. Labs even smaller, actually. Right, under 12, I would say, even pre-COVID, was under 12, because we wanted the students to work maybe in a group of one on equipment together, so both students can get hands-on, or each individual student can work on a project. So labs are even smaller. I think I can't speak for every program. There maybe a physics lecture. They may have. I think they have small lectures, but then they have maybe one discussion that's fairly large.
I guess that's the case. The lecture is pretty big, but the lab, also physics, they have also labs, and the labs are very, very small.
The question was, can we get to know each other as new freshman students? Absolutely. Yeah, we definitely encourage it, to learn, especially the first 3 semesters, as Dr. Ghamari was saying, that you actually get to know students from other majors, and your gen eds, you get to learn students from completely different majors. You may sit in a class next to nursing students and political science majors and history, so we definitely encourage students to get to know each other as freshmen. I know, as a former student myself, there was lots of cool events on campus. They had dances and different ways you could get to know each other. At this time, I know you mean during COVID, I'm assuming. Yeah, it is a different period. Our campus is kind of both virtual and face-to-face at the moment. There are some classes that are meeting face-to-face. There are some classes that are meeting virtually. I know the whole MAC canceled sports last fall. I wasn't just Wilkes, it was the entire area canceled sports. As far as club events, I can't really speak, but I would assume some clubs are trying to hold virtual events, to try to keep it going. We hope that this pandemic ends soon. The vaccine.
The dorms are open, and in the fall, we don't have we didn't have the club hours. But the last email I got from the president, I realized that in the spring, club hours are open. So I guess we're gonna have Tuesday and Thursday, 11 to 1. Club can resume their activity, and that's a good sign. That's a good opportunity. Probably they're following the protocols for COVID. In the fall, we didn't have that. Totally, everything was shut down. But in the spring, the club are gonna resume. And that's a good opportunity, to get to know students from other majors and, get involved with the community.
And, as I was saying, that I think, hoping, everybody's globally is hoping the pandemic goes away soon. But, with the vaccine coming out, there's a possibility that our campus will be much, much more back to normal by the fall. Fingers crossed. But, of course, nobody can predict what's going to happen there. But, I do think a lot of activities are going on, as Dr. Ghamari mentioned, safely. Wilkes has a COVID response team that's been working stringently to make sure that everyone's socially distanced and masks on campus and all that. But I know they do have virtual events to try to help students still, get to know each other. I know the freshman course I taught, we had a virtual symposium. So that's a way that every single freshman has to take FYF 101. They may be in different sections, but at the end of the year, they come together for a virtual symposium, and that's a good way but they could also get to know their classmates at Wilkes as a whole, not just engineering. Okay, great questions. Yeah, there's a lot more questions. Oh, Mohsen, you're still muted.
Sorry, yep. I was gonna say if there is no question, we can probably adjourn. Do we see any new question? I think we answered all questions, right?
Yeah, there's more questions this open house than the last one we did a couple of months ago. That's great. And feel free to email us if you think of something after we hang out. We're available. This is almost a 24/7 job. I'm answering emails at 11 o'clock at night, 12 o'clock at night. Okay. All right, everybody. Well, thank you so much for your time.
Thank you, everyone.
And have a great day.